Hello everyone, welcome back to Blind 75. Today's problem is valid anagram and it's about storing the frequencies, not the values. Here's the problem statement. Given two strings S and T, return true if T is an anagram of S and false otherwise. This means we have two strings which is S and T. If S and T has the same frequency of same characters, then we will return true. So that's what anagram is. Anagram means a word or a phrase that in a rearranged order. Just the change of order, not the frequency of every character. So we just have to match the frequency of every character. Let us see some examples of this question given to us. Like example 1. Example 1 has S equal to ANAGRAM anagram, and T has in the same opposite order, and it has the same frequency of every character in this. The T can be in any order, but we must match the frequency of every character. So if it matches, then we will return true, else we will return false. In the second example, we can see that the S contains RAT and the T contains CAR. We can see that these were not matching to each other. So we will return false simply here. The second index has T, but the T string doesn't contain any T in this. Let us see what constraint tells about this question. The constraint first tells that S dot length and T dot length is greater than equal to 1 and less than 5 into 10 raised to 4. Okay. And the second constraint tells us that S and T consist of lowercase English letters. So we don't have to match the other uppercase and other letters. We just have to focus on the logic of this question. So let us start with a brute force solution. Here we have given the type, like the S has string type, T has string type, and we want to return the boolean. Okay. So I will start with matching their length. The most simplest solution first is that to match. If their length were not the same, then they were not anagram. So I will code here about their length. If length of S not equal to length of T, then we will simply return here false, because if they were anagram, their length should be matched. The one condition was checked here. Now I will check the other conditions, like match the exact frequency of exact elements. So we can't change in a string because a string were immutable. So we can't change them. So I will create here a list, which will be the list of T equal to list T. Now I will loop over S and check in T for char in S. If char in list of T, then simply we will remove it. Then list of T dot remove char. So what will happen here? I've created a list because a string were immutable, we can't change them. So I created a list, and then we will check for each character in S, does this character exist in T? If it exists, then we will remove it, because we want to check all of these frequencies. and if it doesn't exist, then we will return simply false. Now if it exists, then we will remove it, else we will return false. And if this successfully complete, like if we successfully remove all the characters that were in S, we will remove it in T, then we will return in the end, return true. If this operation successfully complete, then we will return true. Let us try this with these two test cases. The second one failed, I think, because of okay, we haven't used the return statement here. Now it will work. Yes, we can see that both the test cases were working, but we don't have to use this in interviews because this has a time complexity of big O of n square. We will optimize it, and this also has a space complexity. We can see that I have created here a list, so this can go up to n number of times. This can go up to n. So yeah, this takes also a space. We will optimize it by using an hash map. Like we can also call it frequency map because we will store the frequency in that hash map. Let me show you with an example. As the input was this, then the hash map could look like this. Like the first character was A, then we will map the exact number of frequencies of A exist in S. We can see that A is 3 times in S, so we will map it with its frequency. I will create here a hash map. We can call it frequency counter or anything else. Frequency. Then I will loop over S. And I will fill the all of the characters values and its frequency in this freak. So if char in freak, then we will increase its frequency. Frequency of char, we will plus it, plus equal to 1. If it doesn't exist, then we will add it in this frequency hash map. Frequency of char equal to 1. Okay, now this will create this hash map we were looking for. Then we will have this kind of hash map with its values and frequency. Then it will be easy for us to loop over T and find the exact frequency of char available in C. Is it equal to the exact frequencies of char available in T? Now I will loop over T for char in T. If char is in freak, then what we will do? We will reduce its frequency because we have counted this one time now, so we will reduce its frequency. So frequency of char minus equal to 1, and we will also check is this frequency isn't going to the negative. if frequency of char less than 0, then we will return simply false here. If it isn't, then if char in frequency of char, we will do minus the frequency, else we will return simply false, and then we will return, if this works perfectly, then we will return true. Let me try the solution now. Okay, this works perfectly. So what we have did in this optimized solution, we have used a hash map to store two things, value and the frequency of that value which exists in S. Then we were looping over T and reducing the each frequency of that character, and also checking that isn't that character's frequency gone less than 0. If it is less than 0, then we will return false. That's it for this solution. If you like this solution, you can see my other videos also. Thank you so much. Bye.